In this section, we'll learn how to multiply polynomials. So there'll be more than one term in one or more of the things that are being multiplied together. Okay, for this one, the first example, we have a binomial times a binomial. That means I need to distribute both the x and the 3 to the y plus 4. I'll start with the x. I'm going to take x times y plus x times 4. Normally we'd write that as 4x. But then I also need to distribute the 3. The 3 will go to both y, or 3 times y, and it'll also go to the 4 as 3 times 4. This large polynomial is our answer. So when you distribute, we'll actually get 4 terms from it. The next one will work the same way. I'm going to distribute this first x to both parts. X to the first times x to the first is x squared. X times 2 is 2x. Now moving on to the 3, I'll distribute it to the x and to the 2. 3 times x is 3x. 3 times 2 is 6. There's the 4 terms. Now for this one I'm going to need to do some simplification because there are like terms. These two right in the middle we say are alike because they have the same variable. So we'll have to put them together. All together in the middle I have 5 x's. So the final answer will be x squared plus 5x plus 6. Notice up here in the earlier example, none of these terms were alike. They did have an x and a y, but not together like this first term, so everything was different. Let's try one more like that since it's so common. I'm going to distribute the x to both parts. X to the first times x to the first is x squared. 9 times x is 9x. Now distributing the 4, or actually the negative 4, I'll have negative 4 times x, or negative 4x, and negative 4 times 9, or negative 36. There's some additional like terms in the middle, once again, so I'll need to combine those together to get x squared plus 5x minus 36. This next example takes it one step further. I have a binomial times a trinomial. There'll just be more work. I need to distribute this first x to all 3 parts. X to the first times x squared. Those are like bases, so we add the exponents. Altogether, I have an exponent of 3. X to the first times 3x to the first. Altogether, I'll have x squared with that 3 in front. And finally, the last one, x times the 2, will be a 2x. Still not done. This 4 now needs to be distributed to all 3 parts. I'll have 4x squared plus 4 times 3x to the first, or 12x, plus the 4 times the 2, or 8. Notice how I've written these a little differently because we do have some things to combine together. This is called the vertical method because we put similar terms or like terms vertically, so it's easier to add them up in the end. You don't have to do this, but it does make it nice when you combine like terms. Now when I look, I know I have an x cubed and then 7x squareds in total, 14 x's in total, and then a number 8 at the end. So this vertical method really helps with combining like terms. What we're going to look at next is a shortcut for problems like example number 3. It's hard to remember that distribution. So this shortcut, some of you may have heard before, it's called FOIL. There's only one problem with FOIL. It only works for binomials. So that last example we did, FOIL would not be applicable. FOILing, however, multiplying a binomial times a binomial, is so common, we're going to spend some time on it. FOIL stands for first, outside, inside, last. It reminds you about how to distribute into the other binomial. First would be the first terms, or in this case, x squared. So that represents the f part of it. Outside are the outside numbers here. The 7 times the x. That's the O. Insides will be those two numbers, 5 times x. And the last numbers, the L, multiply together to give me 35. So it's just a clever way to help you remember what you need to distribute. Now to finish this problem, I'm going to actually simplify. If you notice, these two terms in the middle are like terms, so I have to put those together. I have 12 of those. Try this next one yourself. So stop the video, give it a try, and then check your answer. Let's see how you did. You should have x squared for the first, 3x for the outside, negative 8x for the inside, and negative 24 for the last. Because there's two like terms in the middle, we want to put those together for a final answer of x squared minus 5x minus 24. Here's another one. This is a little bit more challenging just because of the exponent, the variable has a number in front of it. When we start the FOIL process, I have 3x times 2x. That's going to become an x squared, but I also need to multiply by these numbers that are in front, the 3 and the 2. That's a 6x squared. Outside would be negative 15x. Inside is a 4x. And last would be a negative 10. Once again, we have these common terms in the middle. So I'll put those together as 6x squared minus 11x minus 10. Now every once in a while when you FOIL, when you multiply these binomials together, some special things happen. That's what we're going to look at last. We call those special product patterns. For example, if you have a number added to x and that quantity squared, this looks different because it's not written in the same way. But think about what this really means. It's saying square it, or in other words, write it twice and multiply. So it may be helpful to actually write it out yourself. When we FOIL, you'll notice how the outside and the inside actually become the same thing. That's no coincidence. That's always going to happen. Because of that, this number always gets double. So that number became an 8. Again, no coincidence. It's always going to get doubled there in the middle. Look at the next one, x minus 5 quantity squared. That really means x minus 5 times x minus 5. When we do the FOIL process to this one, I get x squared minus 5x minus another 5x plus 25. Here again, that middle term got doubled. Negative 5 times 2 comes out to be negative 10. Just some special things happening. One thing we'll be careful of is this situation. These two things are not equal to each other. So in other words, you are not allowed to distribute that exponent to both parts. This is incorrect. Instead, we would need to write it out twice. So it would look like x plus 3 times x plus 3. In the FOIL process, we do get an x squared, and we actually do get a 9 at the end. But we'd be missing the outer and inner terms. Notably, the 3x and the other 3x. So you can see how these two are not the same thing. That extra 6x is missing if you distribute the exponent. So we'll have to write it twice, no shortcuts on that. The last one is really a preview into another very special product pattern. So important that I went ahead and wrote it out for you. This will have a name later on in a couple weeks for us. It happens whenever you multiply two binomials together and they have the same number, but they switch the signs. So one of them is a plus and one of them is a minus. Look what happens. We'll have x squared minus 7x plus 7x minus 49. Doesn't look special, but when you start combining like terms, these two x terms in the middle cancel each other out. We're left with just x squared minus 49, only two terms. The special product pattern that this is creating is listed here above. Like I said, this isn't the last time you're going to see it. It's a pretty common thing we'll discuss later on in the course. All right, go ahead and give this a try.